Hello everyone, welcome back to this session, and in this session we'll be talking about functions. Python function, like I said, is an important construct in programming generally, and we will be demonstrating how you can write functions in your Python program and call functions to perform that which you have defined them to perform, and how this will make your program more efficient and more readable, and you will be able to extend your program and reuse some of these functions in sections of your program. Let's go straight to Python editor to explore function in Python program. So let's start. The topic we are exploring is functions Python. So how do we define a function? Defining a function or defining functions. So basically the construct is def, I call it def. Let's say we want to write a function that says hello. So the construct is def tells the interpreter that this is a function and this is the name of your function, and remember this parenthesis, open and close parenthesis, is important in definition of function. Let's say in this function we just print hello. We are learning about function. So this is what our function will print out. So if I run this, now we have defined a function called say hello. I can call this function anywhere in this program. Let me say hello. So if I call the function say hello, and let me write something else. This is a function call. So that's a function call. I can call the function again, say hello. So running this, what's the problem here? So sorry, our function here is say hello. Say is say, say hello. So running it, you can see the first say hello does what the function is expected to do. The second line is my print statement here, and the third line is also a call to the function. So I can call the function as many times as possible and it will do what the function has been defined to do, right? So that is the basic construct of defining a function. Use the def keyword, the function name which is chosen by you, and the open and close parentheses. Then you write inside here whatever you want the function to do. And let me mention here, since we have been writing the program, you should note that Python program is indentation sensitive, so you must be sensitive about the indentation. So if you look at this, if I run this, it will tell you expected an indentation block after function call. So you should note that after the function call the indentation should be made, and that works for your function. So we have defined a function called say hello, which can be called anywhere within the program. Let's look at another approach to it. Let's say def print hello. So print hello, we want to say print hello. So, and let's say we have this space. This is defined like this, and now I want to get user input. Let me say your name, and I ask what is the username, which is the question, and then wherever the username is, I can say print, call this function print hello, then the next print your name. So if I run this now, it asks the user what is your name. Let me say my name is Tunji. So entering this, it says hello Tunji because we call this function before we print the name. It says hello Tunji. So this is a pretty much basic example of a calling function. One use of function is if there is a code that you are using over and over in your program, it is good when you encapsulate such code in a function and you start calling it within your program. Let's see another example function. I want to write a function that creates this kind of box. So this is what my function will do. Let's look at how. So let's first tell the interpreter that we are about to write a function, then the name of the function, let's say draw square. Is it square? Draw a rectangle box. So that's what the function do. So we print this character in 15 times. Yep. And the next one, it prints the character one time and print space in 11 times, then the character again one time. So the next print does what? Print the character one time and space 11 times, then we have the star character another time, one time. So the last one will print the character again in 15 times. So we've done this before, having to print multiple character using this operator multiplication. So if you look at this, if I run this, it has created the function that will be drawing square. I can call this function as many times as possible to draw a square, a rectangle box for me. So if I call this function here, you can see draws the rectangle box 3 times. So I can call the function to draw the rectangle box as many times as possible. As soon as it has been declared, I can use it anyhow, anywhere in my program. So another thing I want you to note about defining function is arguments. So for a function can take an argument. When you are defining a function, we call these parameters. You can define a parameters with the function. Let's say we have a function that multiply a number by 2. Then there is a parameter defined in the function which is called number. This is parameter defined in the function which is called number, and whatever you put in as number will be multiplied by 2. So calling this function, you need to provide the argument. So defining the function, we call it parameter. When you call the function and you provide the value of the parameter, then this will be called argument. So if I say this is 55, the argument here is 55. That means the number that you put into the function is 55 and the output will be 55 multiplied by 2. Can you see? So anywhere you call this function, now if I call the function here again and I put let's say 75, the output will be 75 multiplied by 2. So anywhere now I can call the function multiplied by 2 and to do what I have defined the function to do. So this function takes has one parameter, so it requires one argument to run it. So in this case, if you didn't put the argument here, the function call will ask you missing one required positional argument number. So you need the argument to run the function. So that, and we can, apart from having numbers, you can also have text as your argument. Let's make this our box function more interesting. Let me copy this. So this box function takes an argument text. Let's say that. So, and this will be, let me just make it text for simplicity, and I want this one to be text. Let me just take len text. L is equal to len text, that is length of the text that is provided as argument, and this will be star multiplied by L, and let me say star multiplied by L plus 4. So let me leave that star multiplied by L, and I'll say this should display the text here. I'm removing this third line now, and I will say this will be L, right? I will say that will be L. So whatever, if I run this, I've created, okay, let me change this one to rectbox2. I've created another function, and what does this function do? Let's look at it. Let me say here I provided the argument, I call it happy birthday. So if I run this now, we have double quotation here. If I run this now, you can see happy birthday is now decorated by the star argument. I can write any other thing inside that, and it will give me as the argument, and it will provide what we want. I can say my name is Adetunji Adeniran. That's my name, really. So if I run this, you can see that my wonderful name has been decorated in a star box. I'm a star, right? So that's an example of function taking argument. We have created this text box function and this draw rectbox2 function, and we can put any argument inside it. So let's say I have welcome to Colab Learn video series on Python programming. So putting this in, you can see it gives me the decorated output. So you can see that we have created that function, and it's useful for us if adaptively. So more than one argument, functions can take as many arguments as required. Let's say function can have more than one argument. So let's say we have add number, def add numbers. So this adds two numbers, so A, B, and we can say print A plus B. So this prints for us the addition of whatever number we put here, and if we call this function with the argument, with the two arguments, let's say this is 23 and the second one is 77, it will provide us with the addition of both. And if we have 55 and we have let's say 85, I don't know the addition of that, 140. So we can see that the result of the addition is 140. Let me add this to it. Result is this value. So run the function. This will print out result is this. So that is a function taking more than one argument. Let's improve on our box draw box. Let's call it now draw rectbox 3, and let's have another argument, character. So this will take character C, and whatever the character C is what we have here, and here now, and here. So let's see how this works. So if we run this function and we call it again, we need two arguments now, so let's assume the character we will have here is and the text we have here is welcome to Colab Learn Python programming series. So that's the text, and if we run this, you can see the decoration is done by the character we entered. Assuming I have this character in here, then we have, wow, good, lovely one. This looks beautiful. And assuming we have let's say which other character, $, and bravo. So you can see how this function helps us to actually create whatever we want with the design. So that's another application that I want to show you. So another thing I want you to see is that function can return values. So we can return values from function. We can return values from function. Instead of printing things inside the function, we can return values from functions. Let's see examples. So let's say the add number that we did the other time, add number and return. Let's call it add number and return, and we have numbers parameter a and b. So let's define this. This will be result is a plus b. Then we want to do what? Return result. So with this now, we can call print whatever this returns, 4587. So this will print whatever this function returns, which will print what's the addition of the two. So it will return the value. Let's say we can have this should print 20 plus whatever that returns. So it returns the value, add it to 20 and print it. So we have 152. So you can see the difference between a function that returns a value or a function that manipulates a value or prints a value inside of it. So you can return a value from functions. You can return a value from function. Let's write a program using function. Let me copy an image for us to demonstrate what program I want us to write. So let's write a program that actually solve quadratic equation with quadratic formula. So the quadratic formula is in this form. If an equation is in this form, a x squared plus bx plus c is equal to 0, where a is not equal to 0. So we can solve for x with this formula, minus b plus or minus square root of b squared minus 4ac over 2a. So and there is this situation is if this expression inside the square root is greater than 0, there are two real solutions to the quadratic equation, and if the expression is equal to 0, we have one real solution, and if the expression is less than 0, then means there is no real solution to the quadratic equation. Let's write a Python program using function that will provide answer to any quadratic equation given the a, b and c value. So let's say def solve quad equation. So that's the name, and you will supply us with the a, b and c value of the equation. So let's say we have then there is a root value. Let's call it root value, which is equals to b squared, that's b squared, minus 4 multiplied by c. So that's the root square first, that's b squared minus 4ac, and the condition is if is equal to 0, the condition that we have one as in if a is equal to 0, which it should not be, then we can say print valid equation which will cause division by 0, right? Valid equation that will cause division by 0. That is when a is equal to 0, you notice the denominator here will be 0. So now return nothing. It means you return nothing. So else if root value is less than 0, so we first of all test the validity of the equation, which is a equals to 0. A must not be equals to 0. Then else if the root is less than 0, this is when there is no real solution. When there is no real solution, then you print equation has no real solution. We print equation has no real solution and we return. So else if the root value is equal to 0, that means there is one real solution to it. There is one real solution in the equation. X is equal to one value, and then let's get that result. We have the root result is equal to, so if the root value is equal to 0, that means all this will be equal to 0. So plus or minus b plus or minus 0 is minus b. So we can say the value is minus b divided by 2a. 2 multiplied by a. So that's the result. And you now print equation has only one solution, which is returned now. Return results, right? And else means we have tested less than, we have tested equals to. That means the last one is when root value is greater than. Results when root value is now greater than 0, then you have numerator 1 will be minus b plus root value, right? Numerator 2 is equal to minus b minus root value, and x1, the first solution, will be numerator 1 divided by 2 multiplied by, and the second solution, which is I call x2 is equal to numerator 2 divided by 2 multiplied by a. So that's the second x. Then you can tell the user that the print equation has two real roots, which is x1 will be inside result first element and x2 will be inside the result second element, telling the user like that, and return a set of result, tuple of result, which is x1. You can do x1 x2. Good. So running this now, what's the problem? Else we don't need to put anything. Else means the only condition that remains is what we want. So run that. Then we can solve any quadratic equation that has a, b, and c. Let's for example have this. So we have 3 equations here. The first equation is x squared minus 5x plus 6. This has 2 real roots, and let's call our function. Calling our function, the a here is 1 because x squared, a is 1, b here is minus 5, and the c is 6 from that equation. And let's get the result of the equation. Then it says equation has 2 real roots, so let's see the first root and the second root. So x1, let's print our x1, so the results 0, and our x2, let's say x1 is equal to results, and x2 is equal to result x second element, result second element. So we have this here. Let's print and see what our values are. So x1 is 3, x2 is 2. So can you see x is 3 and 2? Let's try the second equation. Which says a is 1, b is minus 4, and c is 4. and C is 4. So let's see what the output of the second equation will be. Let's see what the output of the second equation will be. If I run, it said the equation has only one solution. The equation has only one solution. So we can print the result. We can just print the result, and x is equal to, let's say x is equal to whatever the result is. X is equal to 2. Can you see? X is equal to 2. Let's look at the third one, which has no real root. So the A here is also 1, B is 4, and C is 5. He said equation has no real solution. Equation has no real solution. X, let's see what X come out to be. None. X has no solution. So can you see how we have created the function and it can solve any quadratic equation argument given the correct argument? So that is a use of function. So we can also assign a default argument to functions. Let me just show you that default argument. There are situations which in your programming that you might need that. Let's say we define a function multiple print. Let's say multiple print. Whatever you put here as s should be printed in the number of times you have here as n. So here, let's say the default time is 1. So this means that if you don't provide any value of n, that means the string will be printed in s multiplied by 1. So let's look at what this will give us. So let me call this function, and I don't provide any argument, second argument here. Let me call the function and provide 2 here, and call the function. Let me pull this up for you, and call the function and provide let's say 5. So let's run this. Oh, s is going to be a string. Let me call this one welcome, and we have the same welcome here, the same welcome here. So running this, you have welcome 1 time because you didn't provide any argument and the default value is 1, welcome 2 times, and welcome 5 times. That is a construct of using default argument. So another thing I will mention here is a global and local variable. Global and local variable. I will demonstrate that with an example. Let's say we have a number, num, my number is equal to 50, and we have say multiply, function that multiply by argument. So let's say num and n. So let's say I create another my number is equal to 20, and I return my number times n. So running this, if I call my function and I put 2 here, let me say I print what this returns, and I print my number. This gives me 40 because my number is 20, and this gives me 50 because the global value of my number, this global variable, is 50. So the variable created in this function is a local variable. It's just being created afresh inside this. It doesn't have anything to do with my function outside. If I comment this out, I run this and I print this, it gives me 100 because the variable my number is the one that is created outside here. So if you create a variable that has the same name as the global variable, this is just a copy inside the function. But if you use a name the same as a global variable inside your function, that you didn't create another one, it will use the global variable. So the first one here uses my number, the second one here uses the global my number. So let me use a clearer example to buttress this point of local and global variable. There is another thing that we should look at in this context. Let's assume we have this my list and this my number, and we have a function, two functions. Let's say we have one function there, function 1, which takes a reference x, a parameter x, and multiply that by, and also we have another function, function 2, takes parameter l, and let's say it takes parameter of a list and says list element 1 is equal to 800. So here let's run those functions and assign our list that we have created. Here we have this created, and we say function 1. Function 1 takes the argument, which is our my number 2, and function 2 takes the argument, which is our list. So we expect that function 1 will multiply our my number, the value in my number, by 2, and we expect that function 2 will change the second element in our list, which is 3, to 800. Let's run this function and print my num2, and again print my list. If we run this, we see that my num2 does not change, but our list change. So here we can see that the my num2 is passed into this function. It creates another copy of it. It doesn't affect the global copy. So what happens here is that and you can see that for the list, it actually affects the list. That means the list is referencing the global copy of our list. The function is working on the global copy of our list. So one concept here is that for mutable and variables, there are mutable and immutable variables in Python. Let me write this out for you: mutable and immutable variables. So our strings, integer, double, float are immutable variables, and when you pass them as argument into a function, it's actually a copy of those variables that are packed into the function. So when you change the value in the function, it doesn't affect the global copy. And for the mutable variables like list, set, dictionary, when you pass them into the function, it is the original global copy that the function actually manipulates. And that's why you see that my number doesn't change here, but list changes. So that is one thing we should be aware of. So we can actually access our global variable with in our function. For example, we have function 3, which takes an argument n, and if we want to access that global variable my num2, we can call this global keyword. Let's call this global keyword then my num2, and we can say my num2 is equal to my num2 multiplied by whatever the argument is n. So if you run this function and we say this is 3, if we multiply this by 3, that means the global variable has been multiplied by 3. If I print my num2 now, it will give us the value 60. So we were able to access this my num2 using this keyword global my num2 inside, and we were able to manipulate and change this value inside the function. So this is how you can use a function to manipulate mutable variables, and you can see how it's not you won't be able to change the global value if you put in immutable variable as function into as argument into a function, but you can actually manipulate the global value of a mutable variable if you call the global keyword inside the function that I've shown you earlier. So another thing I want to show you is that function can have variable arguments. You can have variable numbers of arguments, like a list. So let's say def a function. So let's say this is code again, def my function, and this is taking arguments. You can say result for element in arguments. We can say print element. So if you have this function and you call my function, and you had let's say 2 3 4 5 6 7, it will print that for you. If you have lesser than that, it will print that for you and pull it up. If you have more than that, it will print it for you. So any of it will print. We can even say it should return sum of what we have in the arguments. So if you run this now, we can say print to print the sum of everything for you. I don't know the sum of that. Let's see the ones that we know the sum to be sure. We have so 2 plus 3 5 plus 4 9, so the sum should be 9. So you can see it takes variable values and it's perform what we define the function to perform. So this is a brief and simple expository on the functions and how functions work in a Python program. You can explore further how you can make function to improve on the previous assignment. For example, the assignment with the school record, with the class names in the key of a dictionary and the list of students as the element of the dictionary. You can use functions to modularize that program and make it more readable and make those functions more reusable for extending the program or improving on the program. So that's all I want to show you with respect to function in this session. And next we'll be talking about the last component of this series, which is introduction to object-oriented programming. We will look at what object-oriented programming concept is, how is useful to write a readable program, and when your program is big, it is easier to write it in object-oriented programming because you'll be able to debug easily. Each part of your program will function differently and they will function together to give the functionality of the program. So it's a concept that is important when you want to explore, as in endeavor into programming. You need to understand object-oriented programming, especially if you are building a large program. For the examples that we have run in this series, object-oriented programming might not be that clearly useful, but when it comes to bigger program, more that has more classes, more entities within the program, you will need to understand the concept of object-oriented programming. In the next session, I'll be introducing you to this concept, and that will be the last topic in this series, and will give you an appetite, stimulate your appetite to actually explore more and deeper into the world of programming. For now, let's stop here, and I will say happy exploring.